Every morning, as the dew glistens on the vines, we are reminded of the rich.
We don't just pick them when they're big. The key is this creamy yellow spot on the bottom that tells us it's perfectly ripe and ready for you.
This is the quality standard we aim for. And as you can see, the logistics behind us are running smoothly and efficiently. Hoop, hoop.
Speed is critical here. We must get this fruit to the factory fast to maintain those crucial sugar levels.
Every shipment is weighed here on the weighbridge. This data is crucial for tracking yield and ensuring accurate payment for the farmers.
The next step is a rigorous cleaning process to remove all field traces. As we move down the line, you'll see the washing tunnels where phase 2 begins.
This stage isn't just about washing, it's about using the water's density to cushion the heavy fruit's fall from the trucks, preventing microcracks inside the flesh.
The water jets contain a precise, food-safe sanitizer solution designed to kill 99.9% of surface bacteria.
Immediately after, they move under a bank of high-velocity air knives. The camera captures the physics of the drying process. Razors.
Removing all moisture is critical before the next stage, optical sorting, because water droplets can reflect light unpredictably and confuse the cameras.
The watermelons enter the optical sorting chamber, passing under a complex array of high-speed cameras and laser scanners.
Utilizing sophisticated algorithms and near-infrared technology, we can detect internal defects like rot beneath the rind.
The first step is exposing the flesh.
If we crush these seeds, we get bitter tannins. This setter is incredibly gentle, absolutely necessary.
This waste is actually valuable. It can be dry and used for planting or roasted for snacks. It's incredibly efficient.
Watermelons are 92% water, but that remaining 8% is where all the flavor and sugar lives.
We've gone from whole, hard fruit to a smooth, seedless puree, all without heating or damaging the delicate flavor.
While the fruit is crushed, it's not yet smooth enough. This machine applies immense pressure at a cellular level.
While it eliminates harmful bacteria, the beauty of HTST is the flash heating and instant cooling, which completely protects that fresh from the field flavor.
An internal cross-section view of the plate heat exchanger shows the physics of thermal transfer. On one side of a thin,
The aroma is completely unchanged from the fresh fruit. And thanks to the flash process, that cooked taste is completely absent.
The mixture in these tanks is now fully formulated, sweetened, stabilized, and pasteurized, and is essentially liquid dessert waiting to be frozen. The mixture is still liquid at this stage. Beneath this rotating table is a tank of
The camera captures the thermal dynamics. Heat energy, visualized as faint red waves, is being rapidly.
The salt water stays liquid at negative 40 degrees, freezing the watermelon instantly. This rapid freeze.
It's a thermal shock, just enough heat to let go, but not enough to melt the product.
The popsicle is icy and refreshing, frozen instantly in the brine. The sorbet is churned while freezing to add air, making it scoopable.
This isn't just plastic, it's a multi-layered barrier engineered to block oxygen, moisture, and light, preserving.
The flat film is folded into a tube shape around the moving popsicle. The camera captures the precise geometry of the
We emphasize that traceability is key in modern food safety. If there's ever an issue, we need to know exactly which farm the watermelon came from.
Here we utilize our advanced vision system. Camera scan every box, showing green for full, and white.
From this moment until you buy it, these popsicles will never rise above freezing.
From the sun-drenched fields to your freezer, that is the journey of the perfect watermelon dessert.